Hello and welcome back to another video. In this video, we are going to solve the Pure Mathematics 3 October-November 2019 and the code is 9709, component is 32. So we'll be solving first 4 questions in this video. Let's start with the first question. Here's the question number 1. Solve equation 5 ln 4 minus 3x 3 raised to the power x is equal to 6. Show all the necessary working give the answer correct to 3 decimal places. So first of all we'll write ln of 4 minus 3 raised to the power x is equal to 6 over 5, so that we can directly find the value of, we can directly write 4 minus 3x is as e raised to the power this. So it is going to be 1.2 first of all, and then we will get 4 minus 3 raised to the power x is equal to e raised to the power 1.2. How? Because we know if you have ln y is equal to x, it means y is equal to e raised to the power x. As simple as that. Now so you will take I'll take this minus 3 to raised to the power x to the other side, and this will bring it here. It would be 4 minus e raised to the power 1.2 is equal to 3 raised to the power x. Now here the base is 3, so we'll take the log, or we'll take the ln again, ln, and we'll get ln of 4 minus e raised to the power 1.2 is equal to x ln 3. We have used the property ln a raised to the power b is equal to b ln a. I have taken the log both the side, so this is the equation. Now lastly you will write x is equal to ln 4 minus e raised to the power 1.2 over ln 3. So we will get this by calculator, and the answer is minus 0.3512 and all. So we need to write till 3 decimal places, so that is the answer, because the next one is 2, so it would be 1 only. So that's the answer for this question. I hope it is clear. Let's do the next question. Here's the question number 2. The curve with equation y is equal to e raised to the power minus 2x over 1 minus x square has a stationary point in the interval this. For stationary point we know it dx of y should be 0. Find dy over dx first of all, and hence find the x coordinate of this stationary point, giving the answer correct to 3 dp. So first of all we'll find the dy over dx, and we know it is a quotient rule, it is a quotient form, so I'll use the quotient rule here, as well as we'll use the product chain rule also, So we know in the quotient the differentiation is the denominator square, that is 1 minus x square whole square, and then denominator as it is into differentiation of the numerator, and here we are going to use the chain rule. E raised to the power minus 2x differentiation is minus e raised to the power minus 2x, and its differentiation from the chain rule, it is going to be minus 2 plus, no sorry, it is minus, then you are going to write the numerator as it is and then do the differentiation of the denominator. So differentiation of this denominator is 0 minus 2x. So I'll simplify it more. It is going to be minus 2 times 1 minus x square, and I can see e raised to the power minus 2x here and here as well, so I'll write them together plus 2x, and then I'll write this separately, e raised to the power minus 2x over 1 minus x square whole square. I can take 2 also common, and then we'll get 2 e raised to the power minus 2x into, I'm writing this plus and I'm multiplying it, 2 minus 1 minus 1 into 1, so minus 1 plus x square, so it is going to be x square plus x minus 1 over 1 minus x square whole square. So that is the dy over dx. Now we'll find the stationary point. So for a stationary point, dy over dx is equal to 0. That is, this is equal to 0. So we know that denominator cannot be 0. If denominator is 0, it means why it is not going to be 0, because x is in between -1 and 1, not taking 1, so it will not be 0. So only possibility, and moreover the exponent is never going to be 0. Exponent function e raised to the power -2x is never going to be 0. So only possibility to get this dy over dx is equal to 0 is x square plus x minus 1 is equal to 0. So we need to solve this to get the stationary value. So for that we'll use the quadratic formula. X is equal to minus b, that is minus 1, plus minus square root of b square, that is 1, minus into 4 into 1, that is plus 4 over 2. So that is going to be minus 1 plus minus root 5 over 2. So now we got two values of x. Two values of x, but will not take minus, because we are going to get x in between -1 and 1. So if we take minus sign here, it would be more less than -1, so it will not take it. So the only possibility is -1 plus root 5 over 2. We can write as x is in between -1 and 1. So from here we'll calculate it, and the answer is x is equal to 0.6180 and so on. So I'll not write that. X is equal to this. Now for this value, because question number 3, the polynomial 4 x to the power 4 plus 3x cube plus ax plus b, where a and b are constants, is denoted by px. When px is divided by x square plus x minus 1, the remainder is 2x plus 3. Find the values of a and b. So we know the remainder is this. So we can even use the remainder theorem, because we can find the root of this equation, quadratic equation, and we can put it in this, and the remainder will be this. Otherwise we can simply divide it. Let's divide this polynomial by x square plus x minus 1 and get the remainder in terms of a and b, and we'll equate it with 2x plus 3. So let's divide. So if we'll divide this, we know it is x to the power 4, and this leading term is x square, so x square times, and it become x power 4, x square plus into x is x cube minus x square. So we'll change the sign, minus minus, and this would be plus. These two got cancelled, and it is 2x cube, and it is going to be plus x square first of all, because we write in the descending order of x power of x, and then plus ax and plus b, take it down. Now we have the leading term as 2x cube, and the leading term in this is x square, so it would be 2 times x. So let's multiply by 2x, the whole 2x into x square is 2x cube, plus 2x into x is 2x square, and minus 2x. Again change the sign, minus minus, and it is plus. So these two got cancelled, it become minus x square, and it is a plus 2 times x and plus b here, because they are this is a constant, and it is minus 2 here plus 2 here, so I'll write it like this. And again I need to divide by this, so I can see it is going to be minus 1 to get x minus x square. So this become minus x square minus x and plus 1. So if you change the sign, minus become plus, plus and minus, these two got cancelled, and it is 2x plus x, so it is a plus 3 times x, and here it is b minus 1. So remainder, but it is given that remainder is 2x plus 3. So comparing the coefficients, we will get a plus 3 is equal to 2, that is a is equal to -1, and b minus 1 is equal to 3, that is b is equal to 4. So that is the value of a and b. I hope it is clear. Let's do the next question. Here's the question number 4, first part. Express root 6 sin x plus cos x in the form of r sin x plus alpha, where r is greater than 0 and alpha is in between 0 and 90 degree. State the exact value of r and give alpha correct to 3 decimal places. So I'll rewrite it as root 6 sin x plus 1 cos x, and let me equate it with r times, since it is sine, so sin x is already there, so I'll take it as r cos alpha into sin x plus r sin alpha into cos x, so that it will become r times sin alpha plus x, or x plus alpha, both are same. This is the thing. Now we'll compare it and we'll get r cos alpha is equal to root 6 and r sin alpha is equal to 1. So if we square them and add them, we'll get r square is equal to, because sin square alpha plus cos square alpha is 1 for all the alpha, r square is equal to, and it means r is equal to root 7. We could have directly written it root of 1 plus 6, that's fine, r is equal to root 7. Now if we want to get alpha, we have to divide it. So let's divide the sin r sin alpha by r cos alpha. So right hand side would be 1 over root 6. Left hand side we can cancel this r because it's a greater than 0 value, and this become tan of alpha is equal to 1 over root 6. So alpha become tan inverse of 1 over root 6, and that is, by calculator, the answer is, it is 22.207, so 22.2 degree, because they want it till 3 decimal places, so it is not 20 only, it is 22.207, so it would be 208 degree. It was like in habit now, so you always write the answer until 3 significant figure, but we need to take care of that. They ask for the 3 decimal places, so it would be 22.208 degree. So I hope it is clear. Let's do the next part of this question. Here's the second part. Hence solve the equation this is equal to 2. So from the first part we have written this is equivalent to r sin x plus alpha, that is root 7 sin x plus alpha. I'll write the value afterward. Let us calculate everything with the help of alpha, and at the last we'll write alpha is equal to 22.208, so that we don't have to write again and again the whole thing, is equal to 2. So from here we got sin x plus alpha is equal to 2 over root 7, and we need to calculate this value within the just a second, it is 2 theta, so it would be 2. We know now from here we can get 2 theta plus alpha is equal to sine inverse of 2 over root 7, and from calculator this value is 49.1066, so I write 107 degree. And now we need to calculate, because this is 2 theta, so we have to calculate this 2 theta plus alpha for the range of these values we need to check on. So 2 theta will be in between 0 and 360. So 2 theta plus alpha is 22.208. So 2 theta plus alpha would be greater than 22.208 is less than, we'll add 22 here, it is 382.208. So we are going to calculate between 3 to till 382. So next angle for sine, we know it is 180 minus previous angle. So 180 minus 49.107, and this is 180 minus 130.8933. So it is 893. Next angle for this, because it is still 130 less than 382, so next angle will be 2 theta plus alpha is equal to 360 plus the previous angle, that is this. So 360 plus 49.107 would be more than 382.208, so we will not consider this. So the value we'll get for theta from these two. So from first we'll get 2 theta is equal to 49.107 minus alpha, that is minus 22.208, or from here theta would be, it is 26.899 over 2, that is 13.449, so 13.4 degree. I'll take till 1 decimal place, because angle we need to write till 1 decimal place. So next is for this one, from this we'll get 2 theta is equal to 130.893 minus 22.208, that is alpha, and from here theta would be 108.685 divided by 2, which is going to be 54.3425, so it is 54.3 degree. So these are the only values for which this equality holds. So I hope it is clear. So that's it for this video. We'll see with the next 3 questions in the next video. Thank you so much.